So hello everyone in my MBA 502 class again, and this is part 2 now of chapter 7. So what I want to pick up on is slide 11 here where we left off, and the internal rate of return is a complex way of calculating whether you're making money on a project. Okay, so what I want to do is go over that a little bit. And as I said, there are issues with it. This rule, internal rate of return, may disagree with the net present value rule, and it could be incorrect. This one is the net present value is always the standard we go by, okay? So there's three situations where internal rate of return and net present value are going to conflict. Delayed investment, non-existent internal rate of return, and at times there will be multiple internal rates of return. Okay, so these are the three instances where we could have problems with internal rate of return. Okay, let's go over some examples here. So here's the first pitfall called delayed investment. And assume you have just retired as the CEO of a successful company. A major publisher has offered you a book deal. The publisher will pay you $1 million up front if you agree to write a book about your experiences. You estimate that it will take 3 years to write the book. So the time you spend writing will cause you to give up speaking engagements, right? You would normally do speaking engagements, and that amounts to $500,000 a year. You estimate your opportunity cost to be 10%. So the question is, what is the internal rate of return of this? Okay, so if we use Microsoft Excel, and we use the IRR function built right into Microsoft Excel here, you set 3 periods. The present value is $1 million, right? $1 million a year, and this is what you're giving up, right? So that's your payment, okay? So you solve for the rate, right? You solve for the rate in this instance. You can use the IRR function too in, I believe, in Excel. So there's 2 functions that are, compatible. So this is 23.38, and so basically this comes out greater than your cost of capital, right? Let's go back. Your cost of capital was 10%, so this is greater than 10%. So you should accept this deal, okay? So it all looks like you should accept this deal, right? So again, now here's the IRR function in a calculator, and it comes out with the same thing, right? It comes out with the same number. So this is using a financial calculator. Okay, now here's where it gets real interesting. Here's a net present value, and let's calculate that, right? So you're going to make $1 million up front. So here's where net present value shows you how it's backwards. So you make net $1 million up front, right? That's the upfront money you're getting. But then you're going to lose $500,000 a year. So you'll lose $500,000 a year. So those are negative, right? Everyone see that? So it winds up the net present value in this case is negative. Okay, you see that? So since the net present value is negative, the NPV rule indicates you should reject the deal. Okay? So this is where we start getting problems with delayed investments. Okay? So this contradicts internal rate of return. Okay, so if you graphed different if you graph different discount rates and you look at the graph, it becomes very, here's your internal rate of return, okay? Right there, which we just calculated, and we thought that was good, right? Well, here's the graph for different discount rates, and you can see the net present value is negative in all cases. So it becomes real important to graph for different discount rates what the net present value is going to be, and then you get a clearer picture of what's going on here. Okay, you get a real clear picture of what's going on here. Okay, and and remember, the internal rate of return is where the net present value is 0, but the curve is completely flipped around. All right, so this is an important point to look at. Okay. All right. As you may be aware, I'm drinking a cup of coffee. So, all right. It's 5:30 in the morning, by the way. So the next pitfall number 2, is multiple internal rates of return. So, and this is possible. Suppose Star informs the publisher that it needs to sweeten the deal before he will accept it. The publisher offers $550,000 advanced and $1 million in 4 years when the book is published. Should he accept or reject the new offer? All right, so now we've got another cash flow. And let's see what happens now. Okay, so he gives you $550,000 up front, right? And then in the end of the 4th year or the beginning of the 4th year, right? So this is the end of year 1, end of year 2, right? End of year 3, end of year 4, right? You get $1 million, and here's what you're giving up. You're giving up 3 $500,000 payments because you can't, because you have to work on the book. So when we calculate the net present value, we come up with this equation, right? So we get the net present value here. And by setting this net present value equal to 0, we can solve for R, right, to get the internal rate of return. So it winds up in this case by setting the net present value equal to 0, right here. There's 2 solutions to this problem, and that's not good. That implies there's 2 internal rates of return, 7.164% and 33.673%. So because there's more than one internal rate of return, we can't use this. So this is the second pitfall. So now we should graph this. We should graph this and kind of see what it looks like and see what's going on. And here it is now. When we graph it for different discount rates, you can see this is a funny looking shape here. It's a dip, okay? So here's the 2 internal rates of return crossing when the net present value is 0. Everyone see that? So that's not a good thing. Okay. So the net present value is good if you have a discount rate less than 7.164, because this is positive. But then over here again, it's positive if you have if you have a discount rate greater than 33.673. So the point is, you got to do not use the internal rate of return. So the net present value between those 2 numbers will be negative, as you can see here, right? You have negative net present value between those 2 numbers. So you should basically reject this deal. In this particular case right here, you can clearly see that this is less than your cost of capital, so you would reject this. So this is a problem here, okay, with internal rate of return that rears its ugly head. Okay, now let's look at this one. Finally, here's pitfall number 3, a non-existent internal rate of return. Finally, Starr is able to get the publisher to increase his advance to $750,000 in addition to the $1 million when the book is published in 4 years. With these cash flows, there's not going to be no internal rate of return, all right? Let's look at the curve now. Let's look at the graph. Now look here. Okay, there is no internal rate of return. Nothing crosses at 0 to give you a negative net present value. So the internal rate of return is positive for all values of the discount rate. So this can't be used, okay? So again, this is the other pitfall where there is no internal rate of return. I hope I'm clear on all this. So these are the 3 famous pitfalls and why you would specifically use net present value.